Hey, this is Don from Padlock Technologies again with another video. This time we're going to actually go back to basics and talk about MPLS. The reason why I'm doing this because I got a question about my last video. If you haven't seen it, it was about MLDP based VPNs versus GRE. I put that up over here so you can take a look at it. But the question I got was, hey, what is bottom of the stack? Because I said it in the video and you didn't really understand it. So what I'm going to do is I'm going to go through some MPLS fundamentals. So if you're a CCNP, you really want to get at CCIE, whether it's enterprise, whether it's service provider, or you just want to learn some stuff about MPLS, check this video out. Now, I do have a favor for you. If you got some value from this video, please don't forget to share, comment, like, and subscribe. Tell a friend to tell a friend, bring people to the channel, and help them learn something as well. With that being said, let's get to the blackboard here and talk about some MPLS. So, we're at the blackboard. We're going to talk about MPLS. MPLS is probably one of my favorite topics because you can do so much stuff with it. Yes, I hear, SD-WAN and everybody's talking about, oh, get rid of your MPLS circuits and all that. Whatever. MPLS is still here. Will it go away eventually? We'll see. But right now, it's still here. So let's talk about some MPLS fundamentals. Let's go back to school here. So MPLS in a nutshell. All right. Now I'm not going to get into what it means. You can look that up. Whatever. That's not really important. Somewhat not important. So with MPLS, multi-protocol label switching, here's the thing. MPLS is faster than your normal /32 lookup. Why? Because it's a 20-bit lookup, right? 20 bytes, I believe. I always get bytes and bits frazzled in my brain sometimes. So what that really looks like here is if we draw this out, the first 20 is the label, okay? First 20 is the label. The next 3 is what they call the EXP, right? This is QoS functionality, okay? So when you want to do QoS in a service provider network, these are the bits you're playing with. Now, the next one is the bottom of the stack label, okay? Now, this is either going to be a 0 or a 1, okay? If it is a 0, it means it is not the last label in the stack. So that's a quick answer to your question. If it's a 0, it means it is not the last label in the stack. If it's a 1, it is the last label in the stack. And that is usually the VPN label, right? The service label. And then the last one is TTO, all right? Time to live. Now, I said 20 for the label, 3 for the QoS, 1 for the bottom of the stack, 8 for the TTO. And that all equals 32. Okay? Now, when you're in an MPLS network, the forwarding decision is based on the 20-bit label, right? Instead of using if you compare this to IPv4 normal route lookup, IPv4, you'd have to do a 32-bit, right? 20 versus 32, all right? So that's why it's a bit faster. See what I did there with the bit? So that's why it's a bit faster. Now, the genius of MPLS is because you don't have to do this lookup, you can pretty much hide anything behind an MPLS label, right? This is where you got techniques called 6PE, where this is technically, say MPLS, we're just going to say the MPLS label here, and then behind here would be IPv6, right? And this is all running in a IPv4 network. IPv4 network. So you're actually tunneling IPv6 in a IPv4 core using MPLS labels. Okay. if you didn't have labels, you couldn't do it because IPv4 doesn't speak IPv6. So the minute it would get to the PE, it would just drop it because I'm like, I don't know anything about this. I'm an IPv4 core network versus IPv6 network. Now, I think I did a video on 6PE. If I find it, I'm going to put it up here so you can actually look at and see what 6PE looks like. Now, let's talk about some other things from an MPLS standpoint. So, we have different labeling techniques. Now, mainly what you're going to learn is LDP. LDP. That's the main one you're going to learn. Now, once you get into the service provider side, you're going to learn RSVP. You're going to learn BGP. That's a G, right? BGP. And then you're going to know segment routing. And I'll just use SR for short. Right? The main one you're going to learn is this one, right? Because it's an additional protocol, label distribution protocol. You need to have that running in your network so you can, exchange labels and stuff like that. RSVP is when you're going to use something like traffic engineering, right? And I'll explain that in a little bit later. BGP is when you're going to use things like, now depending on who you ask, the name will change, but it's unified or seamless MPLS. This is when you're going to use BGP for labeling. This also works when you're doing inter-AS MPLS L3 VPNs. I know that was a mouthful. You're going to use a combination of LDP and BGP to do the inter-AS L3 VPNs. And then the latest and greatest is segment routing. And this is going to combine the IGP with the labeling function, right? So benefit of that is you no longer need LDP when you're using something like SR, right? Because it takes the same labeling functionality and it actually spreads the labels using the IGP, right? And there's SRv6 too as well. That's just for IPv6 networks. But these are the labelings that you can use in MPLS, right? Depending on what you're going to use for, it will depend your labeling technique. All right. So next one, let's talk some more terminology. So we're going to have regular MPLS network. You're going to hear this terminology all the time, right? Regular MPLS, mainly LDP based. You're going to hear PE, P, and PE, okay? MPLS in a nutshell is a transport technology. That's all it is, right? So it's, hey, how do I get from PE1 to PE2 as efficient as possible without doing a 32-bit lookup, right? That's all it is, right? And in this functionality, you're going to have or in this setup, you're going to have a push or impose the label. The P routers is going to swap the label. Now, in this diagram, this router here, this P router, will do something called a PHP, penultimate hot popping. All right. So what they would do, and if you want to know what, from a labeling standpoint, from an MPLS L3 VPN standpoint, when traffic comes into here, you usually are going to have a service label or a VPN label on top of the packet. I'll say we're going to use the packet here. So this is your IP packet here, the VPN service label, which has a lot more data into it. And then you're going to have the transport label, which is the top label, right? Now this top label is going to be the label from the PE side. All right, it's going to be this VPN label and the PE and the transport to PE. So I'll just say, think of that as the bus. Think of this as the bus. This is the passenger, and this is the passenger. These are the passengers, right? So this bus, as it goes through the network, when it gets to the P router, is going to swap that label with another label. The VPN label stays the same. The IP stays the same. All right. So forth and so on through the network. Now, when you get to that last router, before the actual exit point, that's when this thing called penultimate hot popping happens. Basically, it pops the label off, right? And then you're left with just the VPN label. Okay. Now, the reason why they call it the this PHP process pen ultimate hot popping is because from it, this was the funniest thing when I found out what it was. The router before the entry point, before the exit point, is called the pen ultimate router. So this right here, it's called the pen ultimate router. And then the router, the actual exit point, is called the ultimate router. Why? I have no idea why they did that, but that's what they call it. So the PHP process basically is going to pop off this label here, and then it's only going to have the VPN and the IP packet. Once it gets to the exit point, it pops off the VPN label, and then it sends the IP packet on its way. Now, the good part about the VPN label is you don't have to do a next hop lookup because the VPN label actually has the next hop in it. So it even makes it faster. So now the last router or the exit router doesn't have to actually go into its routing table and say, where's the next hop? The VPN label actually tells it where the next hop is. So that's, in a nutshell, LSPs and all that good stuff. Well, this is called label switch path. Um, but that really tells you how packets move in an MPLS network. It gets pushed on when it enters, it gets swapped along its path, and then right before it gets to the end, it pops off. And I'm only talking about MPLS L3 VPNs right now. It pops off that transmit label, sends it with the VPN label to the exit point. The exit point pops off the VPN label and then sends the IP packet off. Traditional MPLS L3 VPN. Now, what does it look like in traffic engineering? So, somebody decided to be a genius, MPLS TE. Somebody decided to be a genius here. We're going to change some terminology. So, you have the head end of the tunnel. That's the entry point. Then you have the tail end. All right. And then these routers are called mid routers. P routers. For some odd reason, they wanted to call it something different when you call it MPLS TE, right? So what TE does, and this is your MPLS on constraints, right? So basically, you're going to create a TE tunnel from the head end. I'll just use PE to PE because remember, MPLS is a endpoint to endpoint transport kind of protocol thing. That's the technique there. It will send a path message down to the end, right? Saying, hey, create a path. And this is, let me actually tell you, it's a path message. That's what it's called. And that's your constraint. So create a path for me that has, 5 megs available. And what it's going to do is going to use your IGP, your underlay there to build those constraints, right? It's going to look, this is why you have to have a link state protocol and stuff like that. When you configure, MPLS TE and you're using the RSVP protocol, that's going to look and see, hey, based on this constraint, can I find a path that's going to get me to the other side? And once I get that path, I'm good to go. Now, that path message goes down, but when it finds the path, a reserve message comes back. So this way is the reserve message, right? RS. I believe if I'm correct on this, it's RS. Yeah, RE. Don't quote me on this, but I think it's RE RSV reserve. It's a reserve message. That's basically what it's called. I'm trying to remember exactly what it is. And when this reserve message happens, it builds a label. So now the label gets built this way. Instead of using LDP, it goes this way. Okay. And then it uses that label switch path to get to the other end. Now you notice The label wasn't created in the path method, right? From head end to tail end wasn't the labeling didn't start. It's after the constraint was met, and then it found the path, and the reserved message comes back. And when it comes back, every hop will now have a label, right? And then you'll take that label switch path from one PE to the next PE. Okay. Now, BGP method works a little differently. And obviously, you're going to do this when you're doing like inter-AS VPNs or MPLS LD VPNs, or you are doing certain techniques like unified MPLS or seamless MPLS, whoever you ask. So what that looks like is, and I'll make it simple here. If we're talking about unified MPLS, it would look like something like this. All right. So in this entire network, say we have this side, we have this side, and we're trying to get through. So in this entire network, you're going to have your IGP running in this, right? But you're not enabling LDP on this. What you were doing is you're sending, if I'm going to give you the exact, you're going to use this command between all of these. So let's say PE, let's just say PE, right? Now, this same technique is in unified MPLS, but I'm going to say we're going to not use a unified MPLS example on this one. But what you would do is between your routers, you're going to do this thing called send label, okay, on both ends. And then what's going to end up happening is these are going to send labels now via BGP. So the labeling is not going to be via, you know, RSVP or LDP. It's going to be from a BGP standpoint. And again, if you're going to do this for something like unified MPLS, then what happens is what this allows you to do is have different IGPs in your environment, still have labeling going on when you can't see the other side unless you're doing redistribution. But in most cases, you're not going to be using redistribution, right? Now, you're still going to have, let's say if this was OSPF over here, and this was like ISIS, let me use something else, use red. This was like ISIS on this side, and you weren't doing any redistribution between the two, you would technically still run your labeling. You would still run your labeling here, but the VPN label is going to be sent through BGP. All right. No redistribution. Say this would be your next hop. So this would be your next hop stuff right here. And you would send your label in that way. All right. And now you're only going to see this technique usually on inter-AS VPNs or something like seamless MPLS or unified MPLS. I think I did a video on that too. So check out that video if you want to see what unified MPLS, just searching in my videos and you'll see exactly what that looks like. Basically, the setup is exactly what you're seeing here. I'm running different IGPs and I'm not redistributing the IGPs. So they don't know anything about the other side. So I had to use BGP to send in labeling, and then it would go over like I think I had OSPF area 1, ISIS is the core in the middle, and then OSPF area, I believe it was area 2. And then I did the labeling from there. So watch that video so you can learn about unified MPLS. And then last but not least is segment routing. Segment routing, exactly what I said. You can have, I'll just use a simple little diagram like this. Okay. And instead of using LDP, RSVP, not using BGP anymore, you're actually using SR, which Now you have the introduction of a prefix SID, which is usually going to be your loopbacks, all right? And then you're going to have adjacency SIDs, which is going to be the links between your routers. So I'm going to just say a SID, okay? And usually in SR, when you look at your forwarding table, you're only really going to be concerned with going to the node per se. So you're going to have your nodes. So the label is going to look the same on every table. Okay. So let's say this was 6001 here to get to, and this was 600, let's say 9. And this was 16001. So to get to 16009, everybody in this SR domain has the label of 6009. So as it travels through, doesn't it swaps it, but the number doesn't change. So you would think it's not swapping anything. So when it gets to this router, it's it's going to swap it with 6009. And then when it gets to this one, it's going to swap it with 6009. All right? As you keep going through the network. Now, when it gets here, obviously, this would be the PHP process for popping off the label and then getting to the actual ultimate router, which would have the VPN label, and then the IP packet would go on its way. But SR is a new technique that kind of eliminates the use of LDP, but you can run into some issues with SR compared to using your traditional. If you're used to like LDP based MPLS networks, you could run into some issues. But that is, again, MPLS fundamentals. Now, I kind of gave you a little bit more because if you're CCNP enterprise, stuff like that, you're not going to learn about the other three. You're not really going to learn about RSVP. You're not going to learn about BGP labeling. You're not going to learn about segment routing. So stick to the LDP part. Master that. Now, what kind of books you can read to become a master at MPLS? This is an old book, and it's a long book, and it's a boring book. It's almost as dry as Routing TCP Volume 1 and 2. And if you're studying for your CCIE, you got to read those two books anyway. You're going to have to read MPLS Fundamentals. Again, if you think you know MPLS, you will be wide awake when you'll be pretty surprised when you read MPLS Fundamentals, right? Read your Routing TCP Volume 1 and 2. I know there's a debate out there. Do you really need to know that for the test? And again, I always tell you, don't just study for the test, right? Because when you get in environments that are not replicate of the test, you're not going to know what to do. So read it to learn, not to just pass the test, okay? Read TCP, Routing TCP 1 and 2, Volumes 1 and 2, MPLS Fundamentals. You'll be on your way for studying, okay? And that's it. I mean, that's the fundamentals there. I didn't go into like label types because I could have told you there's an implicit null, which is a label 3. There's an alert, which is a label 1. And then there's an explicit null, which I believe is label 0. But those are stuff that you're going to learn in books like MPLS Fundamentals. So I didn't want to make this an hour-long video. So that's it. Hopefully that answered your question, got you a little bit of detail. I kind of answered it in the beginning of what bottom of the stack label means, but you got a little bit of extra. Hope you enjoyed this video. If you did, like I said before, don't forget to share, comment, like, and subscribe. I appreciate it if you already did. If you didn't, doesn't cost you anything but a click of a button. This is Don from Padlock Technologies again. Thank you, and have a nice day.